Hello viewers. So we would be discussing about questions from the chapter radioactivity. Let me tell you, I have already uploaded full chapter, basics of radioactivity. So you can just watch it out, and after watching them, you can try these questions. So as I told you, the questions that I have framed is basically based on the previous year board exam of ICSE, also because you have to increase your critical order thinking. So based on that, I have framed them. Okay, so let us start with the first question. Identify which of them are isotopes, mirror isobars, and isotone. So remember, isotopes are the one which have same atomic number but different mass number. So let us find out same atomic number and different mass number. This one, atomic number 11, I cannot see. Yeah, this one, Y and D, they are isotopes because they have same atomic number, mass numbers are different. Next is mirror isobars. So mirror isobars, I told you, are the ones whose proton and neutron, they are just in an interchange number. For example, let me find out for Z. If I find the number of proton here is 12 and neutron is, when you'll subtract, 11. If you do it for, if yeah, I think this one, if I do it for this one, so here my neutron is 11 and proton is 12. So you can see in this and this, number of neutrons here is equal to number of protons. Sorry, not here, it should be proton and this should be neutron. Number of protons here is equal to number of neutrons here, and number of neutrons here, 12, is equal to number of protons here. So you can see the number is interchanged. So X and Z, they are mirror isobars. And last is isotones. Isotones are uh, the elements which have got same mass number but different atomic number. So let us find out the mass number. Same is 39 and this one. So Y and C, they are isotones. So do remember to revise the definition, then only you can do this question. So this is basically the one memory based, because you need to remember the definition and then only you can understand like which out of these are isotope, isobars, and so on. Okay, now next is why radioactivity is a random phenomena. So this thing I have already covered up, that because you never know that nucleus will break in, any number of, means nucleus can emit any kind of radiation, whether it is alpha, beta, or gamma, and we exactly don't know when this will happen and when it would happen. So that is why it is random. Random means anytime anything could be emitted, right? Okay, so again, this is memory based question because you need to remember why, right? Next is, yeah, this is little thinking order question. How? Let's find out. Uranium 235 is undergoing a chemical reaction, okay, and another uranium 23592 is undergoing nuclear change. Okay, so before you start, you should know the difference between the chemical reaction and nuclear reaction. Let me just brush up what was there. In chemical reaction, the valence electrons are involved, and in nuclear reaction, nucleus is involved, right? Now after that, they are asking us if both the uraniums are kept in electric field. Electric field means where you have a positive or a negative plate, like you do in electrolysis, metallurgy, right? Which one will have their reaction affected? Means ultimately they just wanted to know, out of chemical and nuclear reaction, which one is affected by the electric field. So we have already done that. Nuclear change means wherever nucleus is involved, it is not affected by electric field, magnetic field, temperature, pressure, whatnot, right? So it means that basically you will say the second uranium 235, which is undergoing a nuclear change, will not be affected by the electric field, right? Which one will have their reaction affected? So this one won't be affected. This one, the one which is undergoing chemical reaction, that will be affected by electric field, might be affected, right? After that, if during the above reaction the temperature increases to say 100 degrees Celsius, which will occur faster and why? Okay, so again, we know that the nuclear reaction doesn't depend on change in temperature, whether you freeze the element or you take it to a very, very high temperature. Nuclear reaction, whatever amount of radiations are emitted, that would be emitted, right? So, which one will occur faster? So we can say this one has no effect. This one, the chemical reaction one, the one which is undergoing chemical reaction, this will occur faster. Now compare the nuclear reaction and chemical reaction, 2 points. So here this is again a memory based question. Here you will say nuclear reaction, nucleus is involved. Here the orbital electrons, basically valence electrons, are involved. Second point, you can say that it requires very high energy, and this requires very lesser energy. This was in mega electron volt, this was in electron volt. This difference is given in your book. And you can also write nuclear reaction, this will be not affected by change in temperature, electric field, magnetic field, whether you keep these elements there and then, but chemical one would surely be affected. Yes, now this I already told you in one of my last videos that this was asked in the board exam question this year, that out of these two, not exactly like this, but yes, it was asked that which is more fissionable, right, based on this. So they are saying which is more radioactive. Okay, so again the concept for radioactivity is that number of protons and neutrons, they are unequal. Basically neutrons are more than that of proton, then we say it is radioactive. And you can clearly see here, if I try to find the number of protons, so protons are here 92 and neutrons would be 235 minus 92, right? And here in this case proton is again 92 and neutron is 238 minus 92. So you know that in this case if I subtract, so what will I get? 2 9, this is 6 4 146, and here you will get 143, right? Of course I know both have got a large difference between proton and neutron. You can see neutron here is more than that of proton. Yes, it is radioactive. Here also number of proton is quite less than that of neutron. Again it is radioactive. But if they ask you which is more, so you will see that the more difference between their number will give rise to more radioactivity. So it means this one here, because 146 and 92, and here it is 143 and 92, this would be more radioactive, uranium 238, because you have to remember more the difference, more is the radioactivity. So answer in this case would be uranium 238 is more radioactive. Next is compare alpha, beta, gamma in terms of, and it is written in increasing order. Increasing means smaller to largest. Ionization power. So for ionization power, you have to remember that something which is going to ionize air should itself has a charge, and we know out of alpha, beta, gamma, alpha is charged, this is also charged, and this is neutral. So if I say increasing, so gamma would be the least, followed by beta, followed by alpha. So alpha will cause ionization of the air particle more. Next is penetration power. So we know that the charged particles will not travel to a longer distance, it could be easily stopped. So we know being gamma being neutral, so it will go to the larger depth of any of the material, then would be beta, and then would be alpha. Just remember one thing here, beta is always in between alpha or gamma. Competition is either alpha or gamma, beta always will come second no matter what, right? Okay, now biological damage. Damage, of course, the one which can go more deep will cause more damage. So of course the order will be same as this one, alpha, beta and gamma. Next is speed. Speed, we know gamma travel with the speed of light. So again the order would be alpha being the slowest, beta I told you will always be second, and gamma is first in this case. Mass. Mass, of course, gamma being that compared to that of light, and light has got no mass, right? So this would be the sequence, alpha being doubly ionized helium, so that will have more of mass. And the last is ability to ionize the medium from which it passes. This is nothing but actually first part only. just the language is being changed. So again, this would be the order, because I already told you that if something is charged, only the charged radiation can cause a particle to get charged, and gamma being neutral, it cannot make the particles to be charged, right? And now we come to the next question. Yeah, what is the relationship between parent nucleus and the daughter nucleus after beta emission? So this is actually related to the equations that we do for the reactions, nuclear reaction. Okay, I'm just giving you an example to explain, otherwise the answer would be very direct here. So let a be the, not a, let me take x, so this would be a and this would be z. Okay, if it releases beta, beta means this, and I already told you that this thing, that is the masses, should be conserved according to the law of conservation of mass. So here answer should be z. What should I write here? So that subtracting minus 1, sorry, subtracting 1, I get again z. So if I write here z plus 1, so z plus 1, you can see if I solve them, z plus 1 minus 1, so I get z, so means this is correct. And here it's very easy, a, what should I write here? So plus 0 gives me a, so it is a only. Now they're asking you what is the relationship between this and this, because their mass number is same, so we will say these are isobars, right? These are isobars. Next is, how is beta emission different from the orbital electron in an atom? I told you already that beta emission actually comes from the nucleus. When neutron breaks, it releases proton and an electron. Electron cannot stay inside the nucleus because nucleus is positively charged. So immediately it would be released. So you will say beta emission is actually from the nucleus, from inside the nucleus when it breaks, when the neutron in it breaks. And orbital electrons, of course these are the electron that revolves around the nucleus, right? So next is, name a radioisotope used to estimate the age of the dead plant. So that is carbon 14. Usually carbon has got mass number 12, but radio, they are saying radioisotope, so that is why here it is C14. Next is treatment of cancer. So iodine 131 you can write, or cobalt 60 is also given in your book, so based on that you can write that. As a tracer, tracer is something that is used to detect presence of something here. So here in your book it is given sodium is there, potassium is there, so you can write any one. Now next is, name the metal that can absorb radioactive radiation. So radioactive radiation means all, alpha, beta, gamma. So we usually use lead for that. Lead can absorb, it's a very heavy metal, right? So it can absorb all the radiations. Now this one, yeah, this one I already told you, this has come in the board exam. Which is more fissionable? Fissionable means the one that can easily undergo fission. Fission means breaking. So breaking is easily done by uranium 235. Reason being, even you can use a this one, you can use a slow moving neutron also to break this particular nucleus, right? Now this is quite important, that is question number 11. Most of the times they do give you in the exam to complete the atomic and mass number, and yes, this year also this was asked and this question was asked, exactly the same one, right? So let us do this question now. Okay, now you see here you have to find the atomic and mass number of x and y, and we are going, so here we will go reverse because products are given here, this we have to check. Okay, remember the law of conservation of mass. So let us start from here, this side, 234 and 0, answer should be 234, right? Okay, and here in the product, sorry, in the reactant 4 is already given, so it is understood if I write 230 here, see 230 plus 4 should give me 234, right? So means y mass number is 230. Now here 91 minus 1, the answer should be 90, so means on this side 90 should come. So 90 will come how? So if this is 2, plus something should give me 90. So I think it is clear that something should be 88, because 88 plus 2 will give me 90, right? Okay, now we are going back. So yeah, it's very clear that it should be 88 and 230 only, right? They should have given here, gamma, because see, in only gamma, what happens, the atomic and mass number of an element doesn't changes, and what happens, the energy reduces, right? So answer is 230 and 88 for both of them. Now here also the case is reverse. You're going from x to x3 and answer for x3 is given, so you will go back, right? Okay, let me write here gamma, so that something is to be there, of course. So I know when I take gamma 170 to 69, so gamma will not give rise to any change in the atomic and mass number, so it would be 69 and 172 without any hassle or problem. You can write that. Now here is helium. Helium means it is helium 42. So and it is being released now, so you will write 172 plus 4. That should be the mass number of this particular element. So 172 plus 4, it should be here 176. And here 69 and 2 are already there, so what should I write here so that the answer becomes 71? Of course I'll write 71 here, right? Now it is given beta, so here you will write beta minus 1 0. Now I know 71 minus 1, what should I write here so that my answer comes out to be 71 minus 1, that is 70. Of course I'll write 70 here, then only the answer would be 70. And 0 is already there, 176 is already there, so 0 plus 176 is 176 only, so answer would be this. So this is the answer for the second part. Now I'll just drop this part so that we can understand this. Now you will be trying these 3 questions, right? And you will answer that in the comment section, what answer you're getting for equation number 3, 4 and 5, right? Now the last question for this is, nuclear fusion is not possible at ordinary temperature and pressure. I told you, because nuclear fusion is when you are combining 2 smaller nuclei. We know nuclei being positively charged, and if you want to combine 2 positively charged together, what will happen? You need to supply a very high amount of energy so that these 2 nucleus don't repel each other. And what is that repulsion force? That we say it is electrostatic forces of repulsion. So you have to supply energy to these 2 nuclei so that they overcome that repulsion force. So that is why this is not possible at ordinary temperature and pressure. Do remember to answer those 3 equations. Thank you for watching.